Okay. This project I'm about to explain talks about a typical time series problem. Well, I'm going to start solving this problem using CRISP-DM framework or cross-industry process for data mining framework. Well, let's see the components of CRISP-DM framework. First is business understanding, then the data understanding, followed by data preparation, data modeling, and then model evaluation, and last finally we'll see the insights of the model or how to deploy the model. Well, having these steps will follow these steps of CRISP-DM going forward to solve our problem. Now the question is, what is the problem at hand or the business understanding? So, Global Mart is a giant online store having worldwide operations. It takes orders, delivers across the globe, and deals with all major product categories like consumer, corporate, and home office. Well, business wants to understand the plan for next 6 months. So they want us to forecast the sales and demand or quantity for a given time period. The question is, how would this help them? Well, this analysis will help them to manage the revenue and inventory accordingly. In retail world, there's no need to explain the importance of forecasting, as most of them have to maintain warehouses which help them to stock the product to fulfill the demand. Now, the demands are not same throughout the year, as there might be seasonal demand or normal linear demand changes or any fluctuations due to outcast of any natural activity. For example, of seasonal demand is sales of umbrella in rainy season. Well, moving on to data understanding. If we look at the dataset shared, we understand that there are 51,290 rows having 24 attributes, out of which 5 are numeric and rest are categorical. The retail dataset consists of North, East, West, and Central African region data belonging to 4 years, which is 2011 to 2014. It has customer details, product details, order details, sales, profit, discount, and shipping details. We also understand that the store caters to 7 different market segments and in 3 major categories, which brings us 21 different buckets to analyze. In order to achieve our goal, which is forecast of sales and quantity for next 6 months, we understood the important fields which we need to analyze, which are market, segments, order date, sales, quantity, and profit. There were duplicate order IDs found in the dataset, which were justified the business as each order will be having different subcategories of product ordered by any customer. There were no missing values or outliers present in the data. So we looked at the data. The data now looks clean, and we can proceed with data preparation. Well, as part of data preparation, on plotting the data in terms of critical value, which is a ratio of standard deviation of profit to mean profit, we found not all these 21 buckets are important from store point of view. So we considered only 2 most profitable consistent segment from these 21, and then forecast the sales and the demand of it. The next important thing is time series in sequence of data. In time series, the sequence of data in terms of month of purchase. So we extracted the month details from the order date and store the aggregated sales, profit, and quantity details corresponding to the months for the 2 top segments, which were home, office, and corporate. Then comes the model building. So definitely we are going to choose time series model, as we have to forecast the sales or quantity for a certain time period. But had the business problem been identify the factors affecting the sales or profit, we would have chosen linear regression, or had it been identify the categories of shipment mode or product category, we would have chosen logistic regression or decision tree. But before applying the model, we smoothened the dataset using moving average to identify the trends or seasonal patterns showcased by the dataset. This pattern identification helps us to classify in classification decomposition time series model to fit the linear regression model equation perfectly to separate the trend data. Here, linear regression equation can be exponential, sinusoidal, or quadratic or cubic in nature, with contributing data attributes having additive or multiplicative in nature. In this case, the linear model is a sinusoidal wave with the additive data attributes. So we go ahead and train the model by passing 42-month aggregated sales and quantity time series data for each top 2 segments. Then we separate the global predicted data from the actual data to find the residual data as a stationary data. When we try to analyze the residual data is strongly stationary or a white noise. So if it is a white noise, we can say that the global prediction is sufficient for the forecast. This brings us to a very important part, which is model evaluation. Now, to test the model and understand the output, we will evaluate the model output. First, we will evaluate the residue to understand if it's a white noise or not. We have to use ACF or PACF or ARIMA plots, and then use ADF Dickey-Fuller test or KPSS hypothesis test to prove this is residual is white noise. In this case, the ACF plot and the hypothesis test proves that the residual is a white noise. Hence, we move forward and predict for the next 6 months the sales and the demand. Then we calculate the MAPE, which is the mean absolute percentage error between the actual data and the predicted data. In this case, the MAPE of sales and quantity for each segment varies from 30% to 39%, which is low and good to justify that the model is performing well. As an overall insight, for a giant retail, major segment are home, office, and corporate. As part of forecasting, EMEA market segment home office market sales shows a monthly decline from $3,322 to $2,950, and a monthly quantity starts from 42 to increase up to 48 and then decreases to 41 over the next 6 months. For EMA, corporate market sales and quantity shows a monthly decline from $6,169 to $5,144 and quantity 83 to 76 respectively over the next 6 months.